Yep, and it is now recording, so. And hello, everybody. As folks start to come on in, I bid everybody welcome on this fabulous Thursday afternoon, wherever you are. We're always glad to have everybody on board. We've got a great presentation today with our very own Thad Goodman of National Gypsum, who's going to talk to us about innovative cement board applications, which should be really fascinating. So I'm, sort of giving us a few minutes for people to sort of come in. And yeah, we've got 7. I see Ann Baker. Hello, Ann. And Daniel. Greetings, Daniel. And a bunch of our other folks. Yes. Oh, goody. Good. We now have a February or January presentation. So Ann says hello to everybody. So excellent. I hope everyone is doing really well today. As usual, I'm going to sort of soft pedal and fill for about 5 minutes to give people a chance to come into the meeting. But you are in the right place if you're here for the Cement Board application, for the Cement Board presentation. What I'm going to throw up on the screen is, oops, and this should be, maybe. Are you seeing my screen? Anybody? Oh, poo.
Not yet.
Aha, that's because I didn't click accept. All right, so now you should be seeing my screen. As our new tradition, I am going to take a few minutes before every month's presentation and do a little congratulations to one of our members that has done something wonderful. And this month, I really want to congratulate our very own Dean Bortz, who has now been elevated to fellow. So Dean is our mover and shaker at Columbus State University. He's the student, he works with the college there, and he has been tremendously influential in the Columbus chapter in the Great Lakes region, all over the place, as well as being an absolutely fabulous guy. So our best wishes and biggest congratulations to Dean with his fellowship. And that being said, I have a few more people I want to give a shout out to. I want to give a shout out to anybody from the Bluegrass chapter in the Lexington region that may be joining us this month for our presentation. Welcome, welcome. Always glad to have you, and always wonderful for you to join us. Also, I want to welcome anybody from the Columbus State chapter affiliate program, the CSIS folks. If you have been able to join us, we're celebrating Dean today, so it's a perfectly appropriate time. And welcome, welcome. We always are very happy to see our student affiliates. So I'm going to hand it back. So Thad, you can take over the screen again if you want to put your presentation up. There you go. But yeah, so we're getting ready, and I hope everybody is, well, I hope you aren't quite as busy as I am, because I've been insanely busy, but I think we're all really, really busy. And I'll sort of give it another minute or two and sort of let people wander in. But Thad, what's exciting in your neck of the woods right now?
Just a real quick shout out for the new and revised CCPR program that's coming back online at the Institute. You may have seen the CDT plus CCPR announcement that was made recently from the Institute. I actually got my new manual today, the product delivery practice guide. That's not what it's called. I forget the name of it right offhand. I don't have it in front of me, but the study manual for the newly redesigned CCPR. And so that's something that will come online with this spring cycle. So if you've got some people out there that haven't gotten their CCPR and they're interested in it, I will be doing a study class as we open up as the registration closes. We'll do a study class. Dean and I are actually working on kind of a combination, since it's the way it's going to work this year is you will sit for the CDT if you do not have one, and you will have the opportunity then to continue on to sit in the same day for the CCPR. It's a redesigned test, so it's not quite as robust as it used to be. So they're trying something new, and I think that that's pretty exciting. So that's the newest and latest and greatest thing from CSI where I'm concerned.
Well, that's pretty interesting. So yeah, spread the word to anyone who you think might be interested in the CCPR program. I know it's a great program. It's always been kind of the underdog of the certification, but it's a really worthwhile one. So
yeah, the hope is we can with this redesign and with the new manual and the new study guide, we'll be able to bring some more people to the forefront. We'll be able to get some more participation, because like you said, it's the one that's probably been the most underserved traditionally.
Yep. No, I think that is always worth being aware of, everyone. So it is 6 minutes after, and Roy Sheffley, and I'm sorry if I'm mispronouncing your name, is made a comment in the chat that he is proud to be in the first class of CCPRs, which is fantastic. So congratulations. That being said, it is 6 minutes after. So Thad, do you want to take it away and tell us all about Cement Board?
Thank you, Catherine. I appreciate it. Yes, today's presentation, as you can see, innovative cement board applications with continuous insulation. This program is registered with the AIA. It is 1 LU HSW credit, and I will be receiving that from our company when this is over. I know sometimes those of you that are normal CSInexters realize that we have a variety of ways we deliver it. Sometimes it's from the manufacturer, sometimes it's from CSI, sometimes it's from us as a chapter. This one will come from National Gypsum. There will be a lady named Patty Farrell who will be delivering these certificates. So look for that name in your inbox, and I will send you an email afterwards just reminding you of all this so you'll have a chance to look at it. We have copyrighted this presentation, but if you see any slide that you want or you'd like to have a PDF of this, please just throw it in the chat or email me back when I touch base with you after the program. So our learning objectives today are fairly simple. We're going to focus on a couple of different systems that help accent the outside of the building. And we're going to talk about them both in a traditional adhered veneer and cement board masonry avenue. We're going to define cement board stucco systems. We're going to talk about these systems as they relate to continuous insulation with some of the changes that have gone on in the past few years from an environmental standpoint and an energy standpoint, and then we'll go over some standards and requirements. From a code perspective, depending on where your project is, will depend on which version of the International Energy Conservation Code you use. So the 2021 is here. Our state is not on the 2021 yet, but several states are 2018, and there are still some using the 2015. So depending on where your project is, there are different guidelines that you may want to adhere to, because we've made some changes in the requirements that we'll talk about here in a second in the 2021. So just to outline it for maybe some people that don't know, the IECC addresses the energy efficiency related to cost savings and energy usage across, conservation of natural resources as they relate to the built environment. ASHRAE 90.1 has traditionally been a standard that provides some minimum requirements for energy usage, and these two were combined in 2018. They were combined into the 2018 IECC. So if you weren't aware of that, some new news for you. In the 2021 code requirements, 18 and before, we've seen a traditional, depending on which zone you were in. If you're down in Florida, the zone, the requirements were a little bit less, but depending on the zone that you were in, we've started with the thought process that an R13 has traditionally been something that we felt was adequate for buildings. As thermal pictures have become more evident, and we've started to find other ways to evaluate energy usage, What we found out was an R13 wall really isn't an R13 wall when you start looking at the thermal breaks and the bridging that happens. And so several years ago, they started to move up the requirements by putting something on the outside of the building. So the continuous insulation requirements were fairly stringent. They started with, when you got into zones 5 and above, if you look at this particular map, which is where myself and Mark Algar, Catherine's in 6, we do have a lot of people that are doing work up in 7 as well. We have some people in our chapter that are actually in Canada. So, as we get into those zones 7 and 8, the requirements for base requirements were basically the R13 in the wall, and then you have an R10 was kind of the max in the States. They've actually made some changes since then, and they've gone up R12.5, R18.8 as we get farther up into the changes here. We are in the IECC 2021. So this was known from the start. When they published these in 2015 and 18, they said, at that time it was 7.5, and they said it will get more and more stringent as we go forward. We're going to be similar to what Lee did. We're going to hit you with the first part of this process, and then we're going to make it more stringent as we go on to give people time to adjust and start to find ways to protect their buildings. And again, this is all about reducing that energy usage that we have in the built environment. So at the beginning, there were a lot of people that used the prescriptive method. When they were hit with the changes in the energy code, everybody freaked out and said, okay, how do I move everything outside the building another 3, 4, 5, 6 inches? What do my returns look like? How do my doorways fit? I need some time to adjust. So there was then, and still are, some prescriptive methods that you can meet the energy code without using continuous insulation. Obviously, heat rises. One of the first things that was done was people put more insulation on the roof. That actually helped the coverboard industry. So, that didn't hurt us a bit because we make a coverboard. More energy efficient windows. Windows are traditionally, whether it be energy or sound, they're traditionally a leaking method, an area that tends to be the weak link in the building envelope. So you could do that. From an inside perspective, you start to you move your air changes up and be a little more efficient with your HVAC needs, as well as have a little more efficient lighting. So there are several different ways still you can meet the code, although it's getting harder and harder. There are several different ways that you can meet the code without using a continuous insulation project. But should you choose to put more insulation on the outside of the wall, there are several different options. Obviously, the traditional rock wall has been used on the outside of buildings for a long, long time. It's a little tough to get right now. Several of these products are actually, but from the start of the pandemic, rock wool was harder and harder to get. But it's a great insulation product. It's not affected by moisture, so it's a good product to use. Extruded polystyrene, the blue boards and the pink boards, they can be used both above grade and below grade, and they're great insulators and have been used for a long, long time. Spray foam has been an option over the past couple decades. It started out being more expensive, but it started to move into the mainstream with some of the different changes that have been made, both in the pricing and the application of it, as we get more and more qualified contractors that can put this product on the wall. And we learn a little bit about in those climates like I live in, or like Catherine lives in, or Chris Bennett lives in, where you have a myriad of different things that can happen in a single day, start to evaluate how that weather is going to look on that day, although it continues to be more and more popular in the South, out through the Southwest. Expanded polystyrene, a product that can't be used below grade effectively, but yet it's probably the very first continuous insulation product. When you think about EIFS, the bead board that's put on the outside of a sheathing and rasped to be nice and smooth, and then you put the stoves and the drivets and the Pyrex over top of it, it's a product that's been around for decades, basically since World War II overseas. And then polyisosanurate, it's kind of moved to the forefront in the past few years. It's very effective, highly efficient, with every inch being an R7, And so you have an opportunity to use it in a variety of sources, and we're going to talk more about it as we go on. It too is one that is hard to get right now. So thinking about some exterior applications, there is a wide variety of places that you can use these products. There's a wide variety of designs that have come to the forefront as people get more and more creative with trying to put insulation on the outside of a building and protect that building from the elements, with a lot of different things that go over the top of it. We talked about stucco, cement board stucco, and traditional adhered veneer. There are areas where you can do a direct applied as you get down below the Mason-Dixon line. There are areas where the industry doesn't recommend doing direct applied products to the outside of a sheathing. Just too harsh of an environment. But in all the areas that are, this is traditionally the way that it's been done. Traditional adhered veneer has started with a sheathing. In this case, the picture that we show is a wood sheathing, a plywood sheathing. And then you're going to put a couple different layers of 15-pound building felt on it. They're traditionally going to be stapled to that product. So they're light nails or staples. And then you put a wire mesh on top of that. And then you'll put a type N or a type S mortar over the top of it. So you have the first layer of felt, which is really the one that's the most effective. The other one is almost a sacrificial layer because it's going to get both the mortar that's going to go in there, that's going to create some moisture with it, as well as the back butter of the stone that goes over the top. So it's going to get a lot of moisture, and it's going to sustain some damage, but with the two layers, we know we're safe. So we do the air and weather barrier, the metal lath, the scratch coat, and then we would put stone on top of it, what we call the lick and stick method, where you'd put some on, you have the mortar that was still fairly soft, you'd put some on there, and you'd put some on the back butt of the stone, and you push it on that wall, and you'd hold it for a few minutes till it stuck. That's traditionally been the way that this happens. Almost everything that I'm going to tell you in this presentation, where we talk about putting continuous insulation in this particular system, can be viewed in this slide. We're all pretty visual. And so think about if we take all those pieces and parts that we're using on the right-hand side of this picture, and we replace them with a factory-built panel that can be applied in one application going around the building. Traditional lath and scratch has to have certain requirements for weather, and it's about 6 to 8 pounds per square foot by the time you get it all on there. A cement board married to a polyisosanuret is about 2.2 pounds per square foot. So if you've got that part of it, we're about 3/4 of the way done with this presentation. Catherine, we can stop anytime. No, not quite. Not quite.
Well, I just wanted to make a comment that if anybody has questions, throw them in the chat or throw them in the Q&A, and I will make sure that gets those questions to answer. So I had forgotten to say that. I mean, I think everybody has been on these calls before, and so they know how it works, but just always good to remind. Sorry, go ahead, Ted.
That's okay. Thank you. One of the reasons why this is becoming more prevalent, the slide that we saw earlier, is because of some of the traditional problems that have happened in field fabrication. When you think about type N or type S mortar used to encapsulate the lath, traditionally what happens is when that product goes on the wall, there's an expectation that you're going to get between 24 and 48 hours. Oh, somebody's on. Thank you for muting your phone. So when we think about what's happened is, air gets in here. Sometimes there's air pockets. Sometimes the mortar doesn't have a chance to cure properly, and it's encapsulated where it continues to cause problems with it continues to cause problems with air getting into the lath, and we'll get some rust. And of course, we know nothing's going to.
Please make sure your phones are muted.
Yes, thank you. And then one of the other issues that we have is improper curing. You know, time is money. Time is of the essence. We hear in our CDT training, since we talked a little bit about certification before we got on this part of the call. You know, keeping the job moving is imperative, more and more now so than ever. And so just getting the product done correctly in the field in varying conditions can be an issue. And here's some of the things that happen when it doesn't work correctly. You know, type N and type S mortar are traditionally built to stack stone on. They're not really stuck. They're not really have the holding power to adhere stone to a wall. They can, and they do every day, and we have for years. The picture in the top left, you know, you'll see several of the red circles where there are stone missing. And if you notice the two arches in the bottom, this is the front of a garage. And so this is a part of the building that gets constant vibration as those doors go up and down. And you can see that there's things that have let loose and they've fallen off the wall. By the same token, if you look at the picture on the bottom left, once this degradation starts and water seeps in behind a stone or two, it tends to create a bigger problem. So whatever started, you know, it tends to grow. And then if you look at the picture on the right-hand side, you can see a stone missing there. You know, that might have been a job that it looks relatively new. It looks relatively secure, but here's an area where you've got some high traffic, you know, people walking by, brushing against it with their purse, kids picking at it. They see a stone that sticks out more than any of the rest of them, that sort of a thing. So we've seen these kind of failures enough that there was a demand in the industry to come up with another option. From the standpoint of application and installation, another product that you can have is it's a field fabricated issue. And so we all know that labor is harder to find today than ever. In the past, in the 50s and 60s and 70s and 80s, you know, there were people that had been doing this job. And actually what's happened is a lot of these people have grayed out. You know, I myself used to work in the trades, and, you know, I kind of moved into another line of work because it was easier on my back and my legs to be able to do what I do now, as opposed to, you know, doing drywall for a living every day. By the same token, these fellas that work on these crews have either aged out, and we haven't really had the labor force that's been consistently coming into the marketplace. So there's a lot of young kids in the marketplace right now. There's a lot of transient labor. There's a lot of people that don't have the skill set. A lot of the skilled laborers have retired or moved on. And so you get the young kid on the job and you say, okay, you know, we're going to mix up some mortar here, put three shovelfuls of sand in this mix right here, and we'll put some water in it. Well, which shovel does he grab? Does he grab the cleanup shovel? Does he grab the scraping shovel? Does he grab the measuring shovel? You know, and like all young men, I actually used to be one of them so long ago, I can't hardly remember it. You know, when I was 18, I was going to show everybody on the job how big of a scoop I could shove in there. By about 4 o'clock in the afternoon, when the hot sun is out, it's like, okay, how little can I put on there to get in there? So are we consistently mixing the mix? When we had the professionals out there on a regular basis, we knew that we could. Now today, we're not so sure. So your young labor, and you're comparing this against a cement board factory built panel that's going to be consistently produced by professionals on a regular basis. Then there's the issue of job sites. You know, there was a time, and again, I'm going back to some of my younger days, you know, when job sites were expected to be dirty, and they were expected to be expansive, and they were expected to have a lot of people on them that the normal white collar worker would give them wide berth. Okay. You know, picture on the left is a good example. You know, if you're going to mix mortar on a job, it's going to be a mess. On the right-hand side, you can see they're doing a remodel of an existing office building, and they actually can work right on top of it. There can be people going in and out here on a regular basis.
He left. It's a need in their eyes. He's very close with LeBron.
Thank you, Catherine. So if we think about sheathing options, you know, one of the things that happens is we have to have a sheathing. When we start talking about air and water barriers, we typically have to have some sort of a substrate and a sheathing. So there's two traditional options. There's a wood-based sheathing and a gypsum sheathing. Wood-based is typically more for residential and wood frame construction. You know, gypsum, we see it more often in commercial, although in the past 18 months, all bets are off. We'll use whatever we can get, just get it to the job. But as we think about the traditional way we do things with a traditional primary sheathing, then we have our weather barrier or some sort of a thermal break. And then we have the solid backing for the air and water barrier that helps us to get on there. So the air barrier can go wherever it needs to based on what the exterior system is. In this particular picture, we showed on top of the sheathing. There are certain manufacturers, depending on who you use, that may want it on top of the continuous insulation. There's no wrong place to put it if it's in a proprietary system, and that's where they recommend it. There, by the same token, there are several different methods of air and water barriers. You know, on the top left-hand side, we see a traditional building wrap, which has been around for decades and does a really nice job if it's correctly applied. In the past 15 or 20 years, we've seen spray and trowel applied or self-adhered peel and stick membranes that have gone on in a variety of different ways. We kind of went from pieces and parts to a monolithic air barrier, and now there's a movement afoot to try to start to kind of move back to pieces and parts. So we've seen these things traditionally move around, but the important thing is to know that most of the time in the code is there's some sort of an air and water barrier that's written into the code. Probably the Cadillac system of all of it is when we start to get to a rain screen option. So, you know, there's some sort of a mesh or a mortar or something that goes on the back, on top of the sheathing in front of the weather barrier, where no matter what moisture gets through, it'll weep down into a weep hole and it'll move into that track that you see there, and it'll move across and it'll go wherever it needs to go. So we want to just start to get away from putting the water on the wall and keep it moving down the wall and out the bottom and away from the building where it belongs. So understand that cement board is not a structural product, so you're always going to need some sort of a sheathing. You also want to have one that's moisture resistant, and that would be an ASTM C1325 cement board. There are 3 or 4 in the marketplace. There's 2 or 3 that aren't. So make sure you understand the differentiation between the two. And if you're in a specification mode, you want to specify the C1325 product, which is the better of the ones there. They're inherently mold resistant because this is a factory built panel. You know, it goes up pretty quickly, 4 by 8 sheets, as opposed to having people put on lath and plaster. And then these products also have gotten to the point now where it's understood that they're going to have to be NFPA 285 compliant, you know, if you're using an exterior insulation. And so we have, you know, the people that are producing these type of products have those kind of approvals as well. Some of the different areas where we see this kind of a product used, if you look in the middle right-hand, the very right-hand corner, you can see some sheets of a cement board product that's with a continuous insulation underneath it. There's a thin brick over the top of it in that wide plane. Then there's some EIFS in the middle. You can see in the middle of this building, and then there's some stone in the bottom. So you have a nice solid substrate to work from, and you can put a variety of different finishes over the top of it. A couple other jobs that are out here, typical office building in the top, and on the bottom, that's the Parkland Hospital down in Texas. And one of the unique things about these products is they do have the ability to give you some sort of a curve or a wave in the building. That's not always something that people want, but this was the signature building in this. This was right out front as you came off the main highway in this particular project, and they wanted to have something that gave it a little bit of character. From a standpoint of hospitality, when you think about a building like this, if you look at the stone pillars in the front of this, you know, there's an area where you've got some accent stone on the building, basically designed to help reduce the wear and tear and to protect the building. People milling around there. If you think about, you know, this 24-plex movie theater back in the heyday, there'd be hundreds of people milling out as people got out, other people want to get in. So you've got kids out there that their parents have dropped them off, congregating in different sites. So got a lot of heavy use customers lingering around on the outside. Obviously, the entertainment world has taken a hit in the past year or two, but this was back in the heyday. Here's a job where we've got a traditional air barrier on top of a building. Now, this is like the fourth phase of this particular area. This is down in the Carolinas. In the middle left-hand side of that picture, right below that top floor, you can see right off that little patio there, you can see some cement board on the outside of the building there. They're putting some modified polymer thin set over top of it, and they're sticking stone right to it. You see the stone sitting out in the front of the building behind the two gentlemen, and then just behind that, you can see a pallet of the cement board. The interesting thing about this is we talked earlier about having the space to be able to work in a project. If you look in the lower right-hand corner of this picture, you'll notice there's a curb. That is the street. This, like I said, this was the fourth phase of this, and everything else was behind it. They'd started in the back and built out. And so there's a lot of traffic on that street, and they just didn't have a lot of room. It was a nice, tight little job site, and using the cement board gave them an opportunity to get a substrate up there that was factory built, that was created somewhere else, that gave you the opportunity to save space on the job site. On the outside of a building, there's a limitation of 4 stories without an engineering judgment to go higher, and 15 pounds per square foot, which is a lot of weight, but 15 pounds per square foot to hang stone on the outside of a building. When you get to the inside application for a building, there's a couple things that are different, a couple rules that give you more flexibility. Number one is, if you're just using a straight cement board, you don't have to have a primary sheathing on the inside because you don't have the same racking and weather issues, the same wind uplift and the same wind resistant requirements. So you could put cement board right against the studs in an application like this lobby. And at the same time, you can hang up to 25 pounds per square foot if you want to get just absolutely wild and crazy and put a nice heavy stone on there. So it gives you an opportunity to have some more flexibility inside. Just a quick note to understand there's a difference between the inside and the outside. One of the first questions we get asked is, what does it cost? So this particular video is done by our company. It's a little marketing heavy. It has some trademarks in here, but let me just be fair to everybody and tell you that the cost would be the same. The procedure would be the same with any ASTM C1325 stone in this particular area, any of the competitive products that we compete against. But this is just a study that was done where they took some people that had done lath and scratch traditionally all of their lives. They put some boards in their hand, and then they did a little comparison study where they decided to work one against the other and just see what happened. There's no sound on this particular one that you'll be able to hear. It's just a music anyway, but we'll take a look at what happened. Okay, see if I can get past this slide. There we go. And again, I apologize, that's a little market heavy, and you didn't miss anything by missing the music. Please understand that. Rather dramatic for what we were looking for, but marketing people love to make a big deal out of things. So the takeaways here were pretty interesting. You know, even though these two crews were used to doing scratch and lath, and they had never hung sheet goods at all, and they started and it was almost cool to watch them work. They were a little slow. It didn't take long for them to get the hang of it, and so they hung the cement board in 35% less time. It took 20% less time to install the polymer modified mortar versus the type N or type S masonry mortar. Now, this is important because the polymer modified mortar is more expensive. So you have to make it up in labor. And then these were two storefronts that were built in a warehouse for the purpose of this particular study. And so as the people that were there observing wandered around the back as they were taking their time, as you could see, it took several hours to do this. One of the things they noticed was when they installed the lath, you know, there was all these penetrations in the air and weather barrier over the wood, and 4,400 of them in 275 square feet. You know, because it's attached every 7 inches on center. So when you think about cement board, all of a sudden you've got 550 fasteners for the same 250 square feet, 275 square feet. So a lot less penetrations in that air and weather barrier where we're trying to protect any kind of moisture from coming in. And then in the long run, even with people that were unexperienced with putting the product up, it ended up being $1 a square foot less expensive and installed 35% faster. So think about that as you start to work on these kind of projects. And again, because these aren't as popular, direct applieds aren't as popular in my area, direct traditional stucco, but certainly EIFS and Cement Board Stucco Systems are pretty popular in the Midwest up through the Northeast. You've got a lot of variety, you've got a lot of flexibility, you've got an opportunity to do a lot of different things with your buildings and make them look pretty with working from one substrate. So as we get into stucco terminology, you know, and I won't spend a lot of time on these because we already kind of went over the premium one, and this is basically just an extension of the same thing. Yeah, you've got your traditional stucco that's been around forever. 1 coat, 2 coat, 3 coats, whatever it is, all done pretty much basically the same way. Your EIFS, we talked about how it's probably the original continuous insulation product. You know, it's been around for a long time with the same opportunity to get your air and water barrier, you know, your expanded polystyrene. You can do a direct applied exterior finish with a cement board stucco that gives you the same opportunity to do the same thing with a product that's a factory built panel that gives you a harder substrate, something a little stronger on the front. So just to recap just quickly, you've got a product that's factory built. It reduces time and labor, increases the liability and efficiency of the product going on the wall. You finish it the same way you would traditionally. Any joints that you have, like your EIFS, your board joints would be the same way with a 4-inch alkali resistant tape embedded over all the joints. You try to stay away, like any good building practice we would do on the inside as well. No joints or corners of mesh at the doors and windows. And then the entire mesh would get embedded with a base coat. Again, the flexibility that you have is the same that you would have with a traditional EIFS system. We just saw a finished building. You know, here's one that kind of gives you an idea of what it looks like in progress. Again, you can see on the left-hand side, you see a couple of pallets of product out there, and you can see it quickly going up. You can see that it'd be pretty quick to go up here. And the advantage here, when you look at this particular job, is that it was done in the winter. And this was done in the Michigan area where it was sub-zero the whole time they worked on it, and they didn't have any concerns about getting the product up. A couple other places where we have lots of traffic, people walking around with skis and, you know, heavy coats and rubbing against things, ski resorts, applications like that, multifamily buildings where you can quickly go up with a pretty light product that goes up in maybe some rocky terrain and terrain that's not all that stable to begin with. We talked earlier about up to 4 floors without an engineering judgment. Don't think that you're limited to 4 floors because you can go much higher. You just need to get an engineer involved to make sure that you've got all the requirements that you need met when you start to put light stone on the outside of a building. And then the lower right-hand side, you can see this is the edge of a golf course. That's a golf cart path in the lower left-hand side of that corner. So you can see, depending on how wild and woolly the guy with the big driver would be, you might want something a little stiffer on there than a regular EIFS so that if there's a ball that hits it, they wouldn't leave a big ding in it. Several of the different chains have embraced this type of technology. Dick's Sporting Goods, the Taco Bells, you saw Taco Bell earlier, that was a little more labor intensive, a couple of their new designs. You've got different ways that you can put up light retail applications where you can put these products up and move along right away and still have the protection that you need. If you look at the one on the right hand side, you've got some protection there against heavy traffic, and you've got a little less cost as you go up where you've got like a direct applied or an EIFS up above. We talked earlier about the energy code. The IBC, the 3 versions that you see here, the IBC have embraced this technology as well. There's actually an ASTM standard that approves cement board stucco that was adhered with the C1325 that we talked about earlier. This was originally introduced in 2005. It was reapproved and updated in 2011. So there's some application requirements and detailed instructions that we would recommend that you put in your specifications to make sure the contractor's doing the right thing. By the same token, as we get into adhered manufactured stone masonry veneers, the ASTM C1780 creates a standard practice. And one of the things that's interested in this and the ASTM 1670 is that these have been included and endorsed by the National Concrete Manufacturers Association. That's a big deal for us. That's a big deal for the manufacturers of these types of products, because traditionally, when you think about what the manufacturers are doing, they're trying to create a product that would streamline the process and create less labor. And so at the beginning, the manufacturers or the contractors wanted to kind of stay away from this. They wanted to basically say, you know what, we're not sure this makes sense for us. But as they saw that the labor shortage was there, this has been more and more embraced by people from the contracting end. Again, as we think about acceptance criteria, which is the precursor to a model building code, traditionally acceptance criteria comes out and an evaluation service would be turned in where they would start to look at things from a standpoint of, okay, is this product going to be used on some installation and wind load? What kind of shear resistance are we going to get? Are we going to be able to meet the fire codes? So there are some code bodies out there that are looking to be able to make this a common one. And we expect this criteria to be accepted and become its own ASTM eventually for higher use products without the engineering. If you want fire ratings, if you need fire ratings on the exterior of your building, we can give them to you using a cement board. You can get it with cement board only if you have that opportunity. If you have a situation like that, if you're on the interior of a building that we talked about, we have wood 1 hour fire rating with wood studs. It just needs to incorporate mineral wool to meet the fire test. And then you also have an opportunity to have steel studs with the sheathing that we said was required anyway. So you've got a 1/2 inch or a 5/8 Type-X product on the inside of the wall. You've got a 5/8 sheathing on the outside of the wall, and then you can put your cement board over top of it. And again, the placement of the wind and air barrier would depend on the system that you were using and the manufacturer where they wanted it. As we start to think about what's happened traditionally with cement board, we've seen it used on the exterior buildings more and more for the reasons that we've talked about in this presentation. And we've seen it go over several different types of systems, and obviously the first thing that happened when we started to think about putting insulation on the outside of a building the most common thing that was used was Z-furring. Let's just put some Z-girts out there. We just move everything out in a horizontal manner. We'll put some insulation in them, and then we put something over top of it. And cement board was a logical choice because it wasn't damaged by the weather, and you could adhere to it right away. As other systems have come along, they've been very accepting of meeting the requirements for cement board. You've got the Cascadia Eclipse, the system that's on the right-hand side there from the Canadian people. If Chris is on the call, he can verify that. You've got the night wall system on the left-hand side, as we start to think about just moving things outside the building so that we can start to put that insulation in there, what would traditionally would be the outside of a building. The Foam Sheathing Coalition has had some recommendations for doing several different kinds of batten and metal strips that you can go ahead and connect to when you put the insulation right against the traditional sheathing on the wall. And then the newer product that's out there, the one that we've talked a little bit about and we'll spend a little time here on, is having polyisosanurate married to the cement board. So you can get it in some different thicknesses between a 1 inch, a 3 inch, and a 2 inch. So you go R4, R10, R16. You can get NFPA approvals with polyiso on the outside of a building. You've just got a little faster insulation. There are a variety of clips and nails that need to be used as you move out from the building to give you the wind load and the sag load that you need. There are several different ones here. We'll talk about them in a minute, I guess. We'll move them when we move the proprietary piece of it. So that ends the AIA portion.
I do have a couple of questions for you that have come
Yes.
in. One of them is expansion joint requirements for a cement board for CBU wall. Can you talk about expansion joints?
Yeah, expansion joints would be the same as they would be for any cement board product, which is like 450 feet.
Excellent.
Square feet, I guess I should say.
And then I was very interested to hear, one of the problems I've always had with EFIS is it's soft, and I don't want to use it. I really don't want to use it on the first 2 floors, but definitely not on the ground floor because it gets damaged. And I like the cement board as give me a tougher surface there that keeps people from poking holes in my insulation. Is that been quantified as to how much more resistance that will give you as opposed to a traditional EFIS? Or impact resistance, or
Yeah, I don't
poking.
know that we've done and I will tell you that I don't know if the manufacturers I don't know that any of the manufacturers have actually done any kind of ASTM testing where this is concerned.
Mhm.
I will tell you that from a standpoint of durability, we've seen contractors continually go to it because of that very thing. We've seen owners request it because of the comments that you just made. And then I'll tell you a real quick story about an unusual thing that I got a call not too long ago from somebody who said, "Is this woodpecker proof?" And I said, "I beg your pardon." And he goes, "Is this product woodpecker proof?" And I said, "You're going to have to help me out a little bit. We need to expand upon this question." He goes, "Well, here's the situation. We did an EIFS project near a wooded area, and I have $67,000 worth of damage from woodpeckers."
Ooh.
Because the way a woodpecker works is they land on a piece of wood and they start to peck on it. And if it sounds hollow, they keep going, trying to find some kind of worm or whatever's in there that's caused that wood to deteriorate. So there was enough of them around that they started to attack this building, and they were just poking until they'd find the sheathing, and then they'd go somewhere else and look for some more because it sounded hollow to them. And I said, "Well, yes, sir, in this particular case." So they did a test where they did one wall where they put this up to do some repairs. In that area, the woodpeckers left it alone completely, because once they started to tap on it, it was rock hard, and then they moved on. So we haven't put that in our literature yet, but that'd be an interesting case study. We probably should make some kind of a note about that.
Yeah, well, it's something that I've run into a lot, because EFIS is always an attractive solution because it's less cost expensive, but you can get the appearance, but it's just too fragile to put down where it's going to be in a real heavy contact zone. And so, you know, I always tell my clients, I'm not wild about it on the second floor, but third floor and above, yes, we can go EFIS, but then you start to get into NFPA problems and stuff like that. But it's a very interesting, it could go a long way towards solving the main drawback to EFIS, in my opinion. So, excellent.
Okay. Yeah, good point. Thank you. Thank you for sharing.
I got another with with continuous insulation and CBU installations. Aren't the fasteners a thermal bridge?
Yes, the fasteners would be a thermal bridge. Absolutely. If you want to just glue it on the wall, feel free to do that and take your chances. You know,
Yeah, unfortunately, it's very hard to avoid some sort of thermal bridging.
there
walls,
will, yeah.
Yeah, walls
there
are
will-
usually they take those values and they smear them across the whole surface of the
Yeah,
wall,
and
so to speak.
yeah, and so when we think about, you know, when we think about some of the traditional things that we've seen work, some of the pictures that I showed, the Cascadia, the night wall, the foam sheathing coalition, you know, those are all people that have put the insulation in there. You know, they've extended things out and then they put the insulation in, trying to create as little a thermal bridge as possible. So yes, anytime you have any kind of penetration that goes into the framing, you're going to have some sort of a thermal bridge. But instead of a long bar like a Z-gird, or instead of the traditional ways that we've done things, you're going to have a pinhole in there. And so yes, so the thought process is we're trying to minimize that as much as we can. And like all systems, there's positives and negatives. There's trade-offs that you're going to have to deal with. And you know, from a manufacturing standpoint, with a product like this, all those of us that create these kind of products are doing is, okay, take a look at it, you know, let's discuss the positives and the negatives and see where it works and where it doesn't. And the places that it works, we'll use it. And the places that it doesn't, then we'll help you find another solution.
Excellent.
So, you know, I'll breeze through these really quickly, you know, just to finish up. You know, we're National Gypsum. We have 4 different product lines. Our drywall products, Gold Bond, our PermaBase is our cement board, our ProForm is our finishing products, and we have a roof board called Dexel. Last year we did a low slope roofing presentation here that was well received. The product that we're talking about that we manufacture is called PermaBase CI. It's a product that, as we saw this picture earlier, you know, it's just a polyiso married to a cement board product. It comes in 2 inch, 1 inch, 2 inches, or 3 inches. That's the total depth, not the polyiso space by itself. We can give you some approvals for the NFP 2A 85. It's a product that we're pretty proud of. We think solves a lot of problems, whether you go wood sheathing or masonry veneer applications, stucco applications. We've seen some panelizers embrace it and used it on a regular basis. We talked about fasteners. We have a list of fasteners that I'll be happy to pass on to anybody who's interested in it after this program. Some people that we're doing we've done some testing with. We have some evaluation reports for the 285 that shows it's non-combustible, that can help you out there. And again, the rest of our line is we have a paper-faced product line that's our XP that is mold and mildew resistant. We have a glass mat line that's mold and mildew resistant on the exterior. It's for extreme moisture on the outside of a building with a 12-month warranty. We have all the different finishing products that are needed to handle your job. Our roof boards mirror those, and I'll give a shout out to a former employer and the 900-pound gorilla in this space, my good friends at Georgia Pacific. You know, we have something that mirrors their Dens Deck Prime. So with our Dexel glass mat roof board, our fully adhered or FA board, and then we also have a cement board, a Dexel cement board, for those unique areas where you have moisture from within the building as well as outside the building. And think about an auditorium, manufacturing plant that has heavy moisture inside of it, where you need to have an underlayment or a cover board that would give you protection from moisture both sides. We have some resources that most of the people on this call, if I have a normal crowd in there, would be familiar with. Our Purple Book, which gives a series of best practices of constructability. And it was actually put together by one of our architects on staff. It shows priority legends, joining a 1-hour wall to a 2-hour wall, head of wall details. If you want to cantilever off a beam, what does that look like and how should it be put together? We have a sound book. It will give you 300 sound tested assemblies that look similar to this. It starts 16 on center spacing, 24 on center, wood studs, space, chase walls, and shaft wall systems. There'll be 4 of these on a page. It'll give you a visual outlook because we're all visual. And then it'll tell you down below is there's the description of what it is. So what you think you're looking at is what you're actually looking at. It'll give you an STC rating that's a tested assembly, which is that number you see on the right-hand side by the little arrow. And if you want one of those, we'll be happy to pass those tests on. And those are very important sometimes when you're working with an acoustician or an owner who's very sensitive to sound in a certain frequency. We can give you the test to show you what that looks like in that frequency. We're committed to transparency. We have our EPDs or HPDs and industry EPDs, and most of our products are Green Guard Gold. All of them are Green Guard certified. Most of them are Green Guard Gold. We participate with BSD Spec Link. We participate with Master Spec, VTrue, Deltec. Catherine, you'll have to tell me what their name is today. I never can keep track.
Yeah, wait 5 minutes, it'll change again.
That's kind of why I say that. And then we also have some 3-part specifications that are put together by a CSI member. We've had a couple different specification experts that have helped us develop our 3-part spec, and they're all done in Word documents on our website. And we have some drop-in specs where you can basically just pick and choose what you want and drop it into your base specifications for our products. These can all be found on our website at nationalgypsum.com in our design and resource center. That's where it has the specifications, our lead information, our fire and sound designs, the purple book, the sound book, and some continuing education opportunities. And then if you can't get a hold of me for any reason and you want to call 1-800-NATIONAL anytime between 8 o'clock and 4:45 Eastern Standard Time, you will talk to one of these 3 people. The person on the left is Mark Chapman. He's an engineer that's been with us and does for 38 years. He does all our fire and sound testing and works with UL and the sound labs. The fellow in the middle is Jim Farrell. He's got a former general contractor. He worked for them. So if you're doing CA work out on the field, he's a great person to ask for. And then seated in the front in the purple shirt is the young architect we took off the street in 2008 when the market was down. And he's the one that created the purple book and the sound book. And he's just been a great resource. So if you want to talk apples to apples with an architect and not talk to a product rep like me, you can call and talk to Sammy. So thank you very much for your time today. I appreciate it. As a good audience as always. Any other questions, Catherine, we need to address at the end?
Not really. I mean, George has made a comment that SpecLink is now RIB. Yes, those of us that use the product know that, but I'm sorry, they will probably forever still be referred to as BSD. And but that's just everybody's changing names. But we all know that. We all go through that. Thank you very much, Thad. That was a great presentation. And if anybody is interested in getting a hold of those resource manuals, can they shoot you an email and you can help them make that connection?
Absolutely. Everyone who is on this call will receive an email from me that will give instructions as to how their certificate will come, and they will get an opportunity to hear me say thank you for attending. And at that point, if you just like to respond, that way you don't have to look for me. I'll be looking for you. And we'll be happy to get you hard copies or links to the sound book and the purple book and the construction guide and anything else you need.
Fantastic. Thank you so very much, Thad. This has been really great. And for those of us that don't do this every day, it's always really nice to see what's happening. So great. Yeah, folks, he will reach out and Thad will make sure you get your AIA credit, and he'll make sure that you get your certificates and get an opportunity to get a hold of those resource manuals. We are running right up against our time. We're doing very well. Thank you so much. And I'm going to basically call it a close for this month. Basically stick with us, come back next month, because we're going to have a really great presentation from our good friend Keith Robinson, who's going to talk about bridging the gap between Division 3 and Division 9, and how concrete and finishes and surface texture and concrete moisture and how all of that works together, which should be a really great presentation. So keep your eye out keep your eye on the email for that. It should be coming shortly. And hopefully we'll see you all in December. Have a great month and happy Thanksgiving if we don't talk to you before. So bye, everybody. All right.